Tortajada. She will also present online. Professor Cecilia is professor in practice in Glasgow University, but also a research fellow at the famous Lee Kuan Yew School for Public Policy in Singapore. And I look forward to your presentation, Cecilia. You will talk about wastewater as a source of water and energy. Please, take the floor.
So thank you very much for the invitation to participate today. I am going to be speaking about wastewater as a source for energy and a source of water and energy. And I want to present to you how the world, what are those countries, and within the countries, what are those cities where there are projects to recycle wastewater for indirect potable reuse and for direct potable reuse. In this map, what it is shown, and this was until 2017, what it is shown is the projects that are being, or the projects that are operational and the projects that are planned. The projects that are operational at present are in UK, in Essex and by Essex and Suffolk, reused Belgium, of course, in Namibia, in Windhoek, where it has been operational from 1968 at direct potable reuse. In Singapore, of course, with New Water from 2003 in direct potable reuse. In Perth is in direct potable reuse. The corridor, the Western Corridor project in Queensland, in Australia, was cancelled. But this is how the world looks. However, if we take a close look at the United States, this is what we see. The number of planned and constructed indirect potable reuse and direct potable reuse projects. And we can see the very large number of projects that have been established, that are being operational. In the previous presentations, it has been mentioned the importance of regulations, which of course is also the case when we talk about recycling wastewater for potable uses and even for non-potable uses. And there are cases where the projects, not only in the United States, but somewhere else, in another parts of the world, they have been either delayed or canceled because of public mistrust. So communication has become a very important part of the planning and development of the direct and indirect potable reuse projects. A very important initiative at present in the United States is that the EPA, Environmental Protection Agency, they have established a very large, they are working with each one of the states and the cities in order to discuss the possibility of establishing as a national policy that recycled water can be for potable use. So this is the National Water Reuse Action Plan that had started last year and is work in progress because an enormous amount of work needs to be done in terms of regulation, in terms of health, of parameters, and also in terms of communication. We can see here the number of states in the United States that are considering to use potable reuse, always based on municipal wastewater, in 2017 and also in 2012, 2017. And we see that there is an increase. More states need the water because of what was mentioned before, because there are less options, because of water scarcity, either because of lack of physical water or because of pollution. So clean water is one incentive. The other incentive is that the utilities have to pay to discharge wastewater. So as they have mentioned several times, if they have to pay to discharge the water, they can invest more in order to treat it so that it is cleaner, so it is recycled and reuse it. So this is the second incentive to start so many direct and indirect potable reuse projects. Now, together with the plans, we know we were talking about the regulation. And in US, because it is the most advanced country, there is redundancy in regulations, precisely to make sure that there are no concerns. So we have a redundancy in regulations for guidelines in the cases when they are recommended or actually in place. And what is happening with all this redundancy is that not only the cost, by the cost I mean that the recycled wastewater for potable and non-potable uses has more credibility, but actually that there are less possibilities that there can be any type of problem because of poor water quality, or because the water quality, or because the water was not treated properly. Now we know that a critical component of all the programs starts with the quality of the wastewater, what is called now the stewardship. So it's not only a watershed, but what is our stewardship, so that we know what type of wastewater is being discharged, who is discharging, which requires an assessment. And equally important, educational awareness and public outreach programs are necessary. The water utility that has, one of the water utilities that is best known for the awareness programs and education programs is San Diego in United States. Because after having the plants authorized, they had to close them because the people didn't agree with them. There was a public backlash. They closed it, they had to close it, but then they started a very strong educational awareness and public outreach program. And the plant is about to start again in San Diego. And then, of course, enforcement and the responses and transparency. So our water reuse trends are because of the need of water, as we said. So it is to produce clean water. And for this, we need the regulations, except that there is a big gap between developed and developing countries' regulations, in terms of the regulations themselves, but also in terms of the implementation, the water quality standards. We also have a big gap in institutional capacity, from the financial, technical, regulations again, manpower viewpoint. The foundation of knowledge and expertise is different, and the utility performance, we have to measure it not because of technology, but because of management and governance. And certainly because of the communication, education, and awareness the programs we develop. So within the developing countries, it's been only Bentuk, Namibia from 1968, the one that have been producing recycled wastewater for potable use. And since then, as it has been the case in Singapore, as it has been the case in Perth and the cities in the United States, there have not been problems in terms of public health. So within all our developing countries, what we need in order to diversify our water portfolio is to develop stronger regulations and stronger practices. In terms of energy, I have only one comment, which is a very famous plant in Aarhus in Denmark. Aarhus is the second largest city in Denmark. And they generate now much more energy than the one they need for the plant, which means that they can sell it to the grid. This has made the plant, the wastewater treatment much more efficient, and the operating costs are also lower, considered at 40% of other wastewater treatment facilities, precisely because they are not spending in electricity. At present, they are producing about 2.5 gigawatts of heat for the Aarhus district heating system annually, and they are generating less CO2 emission savings. I mean, they have savings of up to 150 tons per year. And being in Glasgow now and about to start the COP26, I also want to mention of the expectations of the world, so that there is less energy use, that it is used more efficiently, and that is less base we can on fossil fuels. That is my presentation. Thank you.
Thank you very much, Professor Celia. Yes, wastewater is something that we really have to do something about. It is a valuable source, but with respect to the reuse of water, there are social and institutional constraints for using it, and that is in developing countries alike. So it is good to see that these developments are taking place, and of course the energy from wastewater. Why don't we do it? Because it is so clear. You can get more energy out of it than you put into it. So thanks very much, and with that we end the session for all the speakers. We got a nice overview of the challenge. We got also a very nice overview of all the options that are available to us to work on it. So many of those options are technically feasible, but how can we implement it? How can we have the financial means to do it, and how can we arrange the enabling conditions that the implementation takes place? So we finished the presentations, but we do have some time for questions. So please, questions from the floor. So raise your hand if you have a question, and mention your name, your affiliation, your question, and who of the panelists, including the ones online, you will ask the question to. Please, question. Yes. Any question? Yes, in the back. I guess a microphone will come to you.
Good morning. Thank you for the panelists for the interesting presentations. My name is Rana Arda. I work for the Royal Scientific Society of Jordan at the Water and Environment Center. I have a question for Dr. Dawood, please. You mentioned something regarding the closed or controlled agricultural systems in the United Arab Emirates. So my question is, are these agricultural systems like conventional agriculture or hydroponic soilless agriculture? What type of agriculture are you working on? Thank you.
At present, this is a hybrid system. We are using both open agriculture, and recently we started to investment in the greenhouses and net houses. So our greenhouses and net houses started to increase from about 200 units 6 years back to more than 2,200 units at present. And we established what we called it Sheikh Khalifa Fund to help and support the farmers to change from open agriculture to new technology, including greenhouses and net houses. And we have a lot of support to this owner of this farm to improve the situation at present.
Any other question? Yes, please.
Good morning. I'm Amr Sabahi, Secam Company. I wanted to ask or to confirm the question which my colleague asked. She asked about the agriculture methods which you use in these systems. Is this systems according to organic agriculture or conventional agriculture? Because you said it's a soilless culture or hydroponic culture. Did you use chemical or something like this, or you are going to with organic agriculture?
In Abu Dhabi Emirate, we have about 24,000 traditional farms. Each farm, or the size of each farm, between 2 to 3 hectares in general. And all of them are irrigated with groundwater at present. However, we started now to have a project, and by March 2022, we will start to introduce supplying about 4,200 out of them with treated wastewater. In this, because of the deterioration of the groundwater, because they are mainly depend on the groundwater as a supply for water resource for irrigation, we started, some farmers or some owners on their budget, they started to establish or to develop their own small-scale desalination plants. And they started to use this fresh water for using as hydroponic or greenhouse system, and they discharge the brine outside their farms in the desert. So we started a project or a joint project with International Center for Biosaline Agriculture to harvest this brine water for aquaculture. We are discharging it to aquaculture basins to produce tilapia, mainly tilapia at present, and we use the water produced from the aquaculture basins to irrigate Salicornia quinoa and other salt-tolerant and drought-tolerant species to improve the food production and to increase the economic income from the farm. This water as a waste, we start to utilize it and to increase the income for the farm owners.
Okay, thank you. And last question, because the time is up. Who has a last question? Yes, please. Sorry.
I am Isra Sober, environmental researcher at Climate Change Center Department, Egyptian Environmental Affairs Agency. I would like to ask Dr. Ragab about the offshore wind turbines. How can you protect them from the storms, cyclones, and storm surges that are now happening in an accelerated rate than before?
Dr. Ragab?
Thank you.
Yeah. Thank you for the question. These actually floating wind turbines are sort of attached to points in the seabed by anchors, and some of these anchors are of 200 ton of weight. So you can imagine how heavy they are, and there are several ones, at least four anchors, and they are keeping it in one place against all the waves and turbulence. And it seems to be working now for several years. And north of Scotland is really not a calm water, and it has been really tried in Norway as well. Before it was first actually established in Norway, and then it has been at a larger scale applied in north of Scotland. So it seems that the system is working, and it seems to have a free movement to all the fish and whales and whatever really happens in under the water. No restrictions whatsoever, and also it seems that the energy is taken by cable underwater as well, straight to the coastal line. So it seems to be really stable, and it has been there now for so many years, several years, not so many, but for a number of years now, since maybe 2019, and it seems to be stable, and so far no problem was reported about really the stability of them. And it is really seems to be better for the marine biology system.
Thank you.
Well, yeah, we should go. One question, the last question, because time is up.
Thank you so much, Mr. Moderator. I'm Hanan Al-Amin. Hello, everyone. Thanks for the panelists. Actually, I'm having an intervention regarding what mentioned by Cecilia, and thanks for that, and thanks for you. Regarding the Commission of Shoreline Protection in Egypt, how much we could ensure that people are not going to build on the shoreline? Where is the actions by laws and legislations? How it can be inputs? Really, the Delta region is a crisis, especially with the climate change. That people is alongside the Delta region are still building, especially those cafeterias and resort areas. So something like that needs to ensure that the laws and legislations have been enforced. Other issue like communication and knowledge, raising awareness among the communities to be put forward, that to reach the integrated coastal zone management in proper way. Thank you.
Okay, first let's say nowadays and among the project I talk about enhancing climate change adaptation along the north coast of Egypt. One of the main outcome of this project will be integrated coastal zone management plan for the whole coast of Egypt, the north coast of Egypt. And in fact, we expect this project will complete it through the next 2 years. This is one. We expect that mean of the outcomes of this integrated coastal zone management plan is to determine exactly where is the areas we can classify it as a danger area. We will know exactly by the study to determine the setback line of the shoreline, the area where we cannot construct any construction. This is from this study, Integrated Coastal Zone Management Plan along the north coast of Egypt. Nowadays, and through the last 3 decades, in fact, as I said, in 1984, the Irrigation Drainage Law number 12, it indicates that no construction will be in the coastal area in the 2 meters from the shoreline without permission from Shore Protection Authority, the agency which is responsible for all researches and studies along the coast. So already, according to Shore Protection Authority, they already determined where are the danger areas, the areas where we cannot construct any construction, how to protect our natural resources along the coast. And by the year 1994, we got this law number 4, the environmental law. And by Shore Protection Authority and the Egyptian Environmental Affairs Agency, together they already control buildings in the coastal area. And the main result we already put our eyes on is how to protect our coastal areas, how to protect our nature areas. So it's already no construction just built by fault like this. Any construction already, whatever it is, it has environmental impact assessment study, and this study already submitted to WEEE in Egypt and also submitted to Shore Protection Authority and by Supreme Committee. This Supreme Committee I talk about in my presentation, we talk about 6 ministers in this committee. It's already by the Minister of Water Resources and Irrigation with 5 ministers and 11 governors. Together, they already give the decision after technical studies by Shore Protection Authority, especially studies for shoreline stabilization and stability, and environmental study by WEEE in Egypt. Unlike this, the permission already issued here. So between this and that, I think we can control it, and we already control it. Thank you very much.
Okay, thank you very much. And now we really have to close it, the session. Let's get a round of applause for all the presenters, physical and present. And I would like to thank all the participants for attending this session, and I hope you have a very good rest of the Cairo Water Week. Thank you.